Hi, in this video we're going to solve a fairly simple looking equation, negative 2x equals 6. And we're going to do it with two methods. The first way we're going to do is a little bit slower, but a lot of people find it easier. And another advantage is that it's easier to represent with algebra tiles. And the second method is quicker, and some people don't like it as well. So we'll do both ways, and you can choose the method that's right for you. So first of all, when someone's asking us to solve negative 2x equals 6, we just maybe should quickly review what that means. It means we have to find the value for the variable, which is an x here, that makes this whole equation true, that makes negative 2 times that number the same as 6, or negative 2 times the number we're looking for is going to be 6. So we'll just write this down. What value of x makes the equation true? Makes the equation true. All right. So let's start off. We'll come back to that. We might need to just remind ourselves of that. We start off with our written algebra over here, negative 2x equals 6. And then we'll do the same thing. We'll just show it with algebra tiles here. My key with my algebra tiles that I'm using, the red is negative, and the other colors are positive. So negative 2x is two red variable tiles, and it's the same as 6. So on the other side of my little balance here, I'll put 6 positives. There we go. So one thing that many people are inclined to do right away is to divide both sides by 2, which we can show with the tiles by splitting it into two groups on both sides here. And we'll show with the algebra by just showing that we're dividing by 2. So I'll copy what we have, negative 2x equals 6. And then I have another color, so I'll use it to show what we're doing. We're dividing both sides by 2. And then that gives us, so now when we do our division by 2, we've split it into different groups, and now we're going to focus on one group. That's sort of an interpretation of what division means. So now we've got just negative 1x equals positive 3. So negative x equals 3. Now I think it's a reasonable point that maybe needs to be made that we're actually not finished yet, because we don't want to know what value of negative x makes the equation true. We want to know what value of x makes the equation true. And you might see right here, it might be obvious at this point, or for a lot of other people it isn't, or they have a guess, but they're not exactly sure if or why it would be true. So we'll go through some algebraic, some operations. We'll do some operations to the equation to show what the value of x must be. So we've got negative x equals 3. We would really like to have positive x all alone on one side of the equation, on one side of the balance, or on one side of the equation here. So at this point, what I'm proposing to do is to add x to each side. So here's why. If we add x to each side, we'll have an x over here, and that will be positive x, which is what we want. And we'll have as 3 as well. We'll have to deal with that later. So we'll have, and over here, the positive x and the negative x will make a 0 pair, so that will be 0. So then we won't have any negative x's in our whole equation. So that'll be kind of more convenient. All right, so we'll do that with the algebra tiles. And then we'll do it with our equation as well. So I'll use my other color here, negative x plus x equals 3 plus x. All right, and then negative x plus x, this is 0. It's a 0 pair. So because it's worth 0, I can get rid of it without affecting the balance or the equality of the equation. So on my left side here I have 0 equals 3 plus x. So this, maybe you're not used to having nothing on one side of the equation or having 0 on one side of the equation, but at this point we're in a better situation because our x is positive, so it's a little more obvious what to do now. Now we can think if we'd like to get rid of this positive 3 here because we'd like to isolate our x. So how could we get rid of positive 3? One way is that we could subtract positive 3. Which would be great. Some people might not be sure what to do, especially with the algebra tiles, if we were subtracting positive 3, but we didn't have any positives. So if you're comfortable doing that, you can do it. What I'm going to do, which means the same thing as subtracting positive 3, is I'm going to add negative 3 to both sides. Mostly because I think it's easier to see with the tiles what's happening. It's exactly the same as subtracting. Adding... It'll be real clear there. Adding negative 3 is exactly the same as subtracting positive 3. Okay, so I'm just about to do that. I'll write down what I'm doing. So here I had 0, 3 plus x, and I'm going to add negative 3. On both sides. And now I'll do it. So over here, that's fairly simple. I have negative 3 here. This is why this is a useful thing to do. Because my negative 3 and my positive 3, they make a bunch of 0 pairs, which is worth 0. So again, we can eliminate that without affecting the value of this side. So what we have here, 3 plus x plus negative 3, those made the 0 pairs. This, as we can see, is just worth x. And over here, 0 plus negative 3 is just worth negative 3. So here's our solution. X is equal to negative 3. I'd like to make another point. I said that we want to know the value of x that made it true. Now, x can be worth a negative number. That's no problem. But up here, this wasn't the solution yet because we didn't know how much x was worth. We knew how much negative x was worth, but now we know how much x is worth. X is negative 3. So this is the solution to the equation. If you substituted mentally here, negative 2 times negative 3, that is positive 6, which is what the other side of our equation says. So that's a quick way of checking mentally that this negative 3 equals x is a solution to the equation. Okay, I'm going to show you another method here, which is a little bit quicker. This method rests on you being comfortable dividing by negative numbers. So if you are, then you might really like this method. If you're not, you might prefer the first method here. So negative 2x equals 6. At this point, we can actually sort of do this in one step. We can divide both sides. Instead of originally we here divided by 2, if we divide by negative 2 on both sides, negative 2x divided by negative 2 is x, and 6 divided by negative 2 is negative 3. And that is the same solution we had over here. One disadvantage I think it's pretty hard to show dividing by negatives with algebra tiles. It's more confusing than it is helpful, in my opinion. So if I'm drawing tiles to show something, I would always rather use this method, but other people would prefer this method. All right, thanks a lot.